Okay, hello everyone. So I just wanted to take some time to give a little bit of context into what I do on my side projects, what I do on my free time. I don't normally get the time to talk about such subjects. I don't get the time to talk about video game design and things like that. And specifically, I wanted to talk about something that everyone seems to have this idea that video games and the industry, there's something about it that's not super serious. I kind of got this vibe all the way back in high school, and now that I work with real engineers, I still sort of have this idea from people that video games can't be serious and really aren't ever serious. I just wanted to give a little bit of context of why I don't think that's true. I will say what is true is we all know from video games there's always a chance that you can make a game in under 24 hours. We know of a very famous case. It's a game called Flappy Bird, right? This is definitely a game that you can make in less than 24 hours. Um, and one of the reasons why it isn't too difficult to make, right, is you play as this bird, and this bird only has two inputs from the user. You can go up and you can go down. The phone or the screen is constantly scrolling this way, right? You can never go to the left, right? So the only thing that the game developer really had to worry about was the user either going down or going up, and everything else was handled by the background simulation of the game. For instance, these pipes that are coming at you from this direction. I guess one difficult thing to say about Flappy Bird is that you did have to figure out how these pipes were going to be generated because it's not like these pipes were hard coded in some file somewhere. I'm sure the game developer, I mean, I guess that could be the case, but more than likely the game developer had random heights and pipe sizes uh, that would come from this direction and they would be generated randomly, right? The developer wouldn't know what pipe is coming up next. So it is possible that video games could be created in a short amount of time. And in cases like those, there's indie jams all the time where the goal is to make a game in less than 24 hours. And some of those games you can say aren't shouldn't be taken too seriously. If you compare them to other technical fields where engineers exist, you could probably say those video games aren't equally as serious to the degree of other technical fields. However, that's not to say that all of them, even the 24-hour mini jam ones, that's not to say that all of them aren't that serious. There's something to say about the video game industry that I believe, and it's that you could have equally, um, probably how do I put this? Probably the simplest version of an engineer all the way to the most hardcore version of an engineer. And both of those categories could belong in the game industry. And probably that's something you could say about any field, but I think it's more serious, the video game field, than any other field. The reason for that is video games have this nice tool that you don't get in any other field that's engineering discipline. It's that most of the engineering process happens in this visual manner. And whenever you're able to see data in a visual way, um, which engineers are very tied to, you're able to you're able to work on that data in a much faster rate. And because you're able to work on that data in a much faster rate, you're able to innovate in a much faster rate. And engineers like innovating on things. And because of that, some of our greatest engineers just end up flying to the game industry. Um, yeah, I'd almost say even to the level of NASA engineers. And the only reason I say that is there's a ton of good developers, there's a ton of good engineers that started in the game industry, and there's some that still are in the game industry. One of the best examples of that is John Carmack, which he himself in his younger years, I'm not sure if it was while he was big, maybe after Doom era, um, but he took this tour to see the Mars rover, and he was able to look at the code. And while looking at the code, he was able to optimize the code for the Mars rover, right? A space style, very professional engineering project, and this game developer optimized the code for it, right? There's some really serious engineers in the video game industry. I also just want to highlight some points as to why another reason why I might be able to make that case. Um, so some of the stuff that happens in the video game industry is physics. Lots and lots of physics happens in video games. Without physics, games wouldn't feel very realistic at all. If you base the game that you're trying to make off the real world, then you have to use real world physics. And if the game feels like something that we're already used to in the real world, then it's a much better experience for the player. They're more used to, like, say, gravity. They're more used to gravity that they're used to seeing in the real world. They're able to see that in the video game, then suddenly it just feels better than if it's something that's abstract and they're not used to. Um, Another great example of that is like water. Um, if you've ever seen water in a video game, right? Someone had to code that. Someone had to know how the physics of water works, and they had to display that in a video game. And not only that, but if you imagine what engineering in a video game is, basically programming, you're describing in a lexical way, you're describing with words and sentences how this water exists, basically, how this water matches the real world, and how the physics of the water matches the physics of the water in real world, right? Someone had to write that, and it's always going to be different on different games because it's always a different engineer that has to work on that, right? You don't just repeat the code that um some other person did. You can do that. There's another even easier layer of engineers that's underneath the simple engineer that it makes a game is if you have enough money, you can just pay for every single asset that you need and even pay for the programming of the game. And yeah, and then you have yourself a game like that. So video games also have to be constrained by the hardware. You know, they have to make these big, massive things that if you think of something like Fortnite or Apex Legends, GTA, any of these big games, you've got these bullets that are coming at you. You got 50. In the case of Fortnite, you got 100 people playing this all-out warfare, where bullets are getting shot out of the gun, as fast as bullets in real life are. And the video game's got to keep track of every single bullet that's fired from hundreds of people, as well as like messages that might come up if you're trying to chat with someone or you're using voice chat on on the game console itself, where you have your headset in, and you still gotta communicate with your friends over voice chat, right? All this is going on in the video game, and it's got to be done. The video game's got this constraint most of the time where it's got to be done in 60 frames per second, right? It's got to do all this networking stuff and all this bullet calculation stuff, collision physics. It's got all kinds of stuff that you got to worry about. The animation of the character, and it's got to hit that 60 frames per second constraint, which for people that might might not be familiar with this kind of thing, that's 33 milliseconds each frame. And what that abides to is 33 over 1,000 seconds. So, you know, that's not a lot of time to do all that, right? Another thing you gotta do that involves physics, right? There's audio. If you want the soundtrack to sound good, you want audio to play at all, you got to manage the physics of audio. Someone's got to write code that translates music into something that plays out into a device. And so they got to know how wave frequencies and sound waves work. And, if you're crazy, you can make stuff like reverb and all sorts of effects that are added into the game, and normally more than one type of sound effect is playing at a time on a single frame, right? You got the music playing in the background, you got someone talking on the Xbox live chat, right? Then you got the player, the actual character saying something for some reason, and then you got the sound of a car moving behind you, and as it gets closer, the sound's going to get louder. All of that comes into play, and again, for this to feel good to the player, it's got to be as realistic to the real world as possible, right? And so one of the things that I've been told over the years, and I sort of laugh about it in my head whenever I hear it, because I don't want to explain this to people that normally say it, but a lot of people all the time tell me, well, it's come on, it's not rocket science until it is, right? Imagine we're playing or we're making No Man's Sky, right? You know what No Man's Sky has in it? Well, that was a terrible rocket. Oops. Whoops. Anyway, I gave the answer out. It has a rocket, right? So even some games, if you're gonna have rocket and space and stuff in your game, and you want that to feel realistic, you want that to look as real as it does in real life, guess what a developer has to do? They have to know a little bit of rocket science. Um, I'm not kidding around when I say I think some of our best engineers in this world work on video games. Now, I don't know. I'm not going to say all video game developers are best engineers. I'm saying there's a handful of them, and they're in the game industry. Um, yeah. I really don't want to go into detail into things, and I want to keep this short. I have a few things set up here. I want to show you. Um, just one thing to prove my point here. If video games weren't as serious as I thought them to be, right? Like if they really didn't take a huge engineering effort to make, then you wouldn't have numbers like these. So imagine GTA 5, right? I guess I should have looked before I started this. I don't know how long it took to make. I know GTA 6 is well over 10 years now, I think. It's getting close to 10 years, if not. But GTA 5 had a team of over 1,000 people, right? One game, one $60 product, over 1,000 people, right? That's insane. Borderlands 3, about 350 people. The Spider-Man for the 2024 release, about 450 people. Red Dead Redemption 2, about 2,000 people. The God of War, about 300 people. The Last of Us, I should have changed this. I'm not sure what number this one's actually giving me. I guess this is for Last of Us Part 2, and I guess it's saying 2,100 people, but that's a huge, even if it's just the 350 people, right? That is a lot of people for a single product. It's on the shelves. I mean, it's on the shelves forever, right? You can still buy Dead Space even today, right? That's a PS2 game. You can buy a PS1 game even today, right? It's sort of it's 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 a product that will always has potential to sell each year, right? But these things take forever to make, and they really do take a lot of people. So these are all sort of just my understanding, my perspective, my assumptions of what goes on in the game industry and why I think it should have a little more of a serious factor when you're talking about the people that work on these things. But just to add a little bit more, um, I've saved some of these talks, um, and they're only a few seconds. These clips that I'm going to give, I give the full things on the in the description below. But this is Mike Acton from CPCon talking about data-oriented design. You don't need to know anything about that. This small 30-second clip, he's talking about what he specifically does on his team. He's the he's the I don't remember if he's the engine director or if he is the technical director, but these are the guys that made Sunset Overdrive, and he describes here a list of what he does for the audience in his work.
So we, as a team, generally build the runtime systems, especially the systems that require the most performance, are the most used in a game as far as the amount of data that's being transformed. So examples are the rendering system, animation and gestures, streaming, cinematics, visual effects, post effects, navigation, localization, basically all the big kind of systems that are not specifically the game itself.
So he's kind of giving an overview of the type of stuff that the engineers have to think about before even the concept of the video game comes about, right? All these tools you need to have made, you have engineered before the developers start even working on the game, right? That's a really important thing to talk about because there's a lot of stuff that goes into making a game even before the game starts being made, right? One of the things that most people wouldn't ever think about, right? It's a list of a lot of stuff. Here's another one. This guy is Jonathan Blow. This one's a more sarcastic one, as in his lectures, he has someone on Twitter describing, giving a list of how much they got to do to justify the number of employees that they have. And Jonathan Flo is an independent game developer. He makes most of his games mostly from scratch. Uh, if he has a team, it's not very many, probably less than 10 people. Um, and he gives a list of what, some things that he had to do. So
Is okay, maybe it's really this complicated. Maybe, okay, you've got to do all that stuff. That's a lot of people. But you know what? I just shipped a freaking video game on a couple of platforms. And if I were to list out all the different things we did to ship that, it would be a really long list. I could certainly make you a lot longer list than this if you're trying to compete for length of list, right? Like, freaking internationalization. I did internationalization for 16 languages on this game, including programming for freaking Arabic, which was really annoying. Because sorry for people who speak Arabic, but the thing that makes it annoying is it's right to left, whereas most languages we deal with are left to right, and like, so every screen, never mind, I won't go into it. The language itself, I'm sure, is very beautiful, but when you've got like 2 weeks to make it work, it's like, oh my god. Fortunately,
so it also goes into another thing that makes video games stressful sometimes is we have hard dedicated deadlines, which most technical product projects, and I don't know why, probably because they're infinite money grabbers, but most technical products don't have deadlines. They have this cycle where they're able to constantly update over and over. Video games can't do that. They have to make a sequel or something. Most of the time, it's not like most of the time, if they update something on a game, it's like a bug fix. But usually what you pay for is the end product. Um, it's starting to become less and less true as DLC has become more popular, but that's mostly true. Um, and there's this third clip. I don't remember. So this clip more relies on it more brings up the point as to how much of a technical feat it is to make a game, and this is more what I expect from the engineers that are actually really, really good engineers that come from the game industry because these guys have been here since computers started. And what this guy is about to describe is that there used to be a time where video games, you didn't just have to make the tools for the video games and the video games themselves. You also had to make the operating system that the video game ran on. So you even had to make the networking stuff and the file IO stuff and everything underneath that for your game to work. So it's a little interesting.
About it. We know that in the past, hardware that was very capable and very interesting made it so easy to create an operating system that literally everybody did it. Not a few people, not even most people, but literally everybody. Like, I don't even remember, there's like 3 games I can remember that shipped on the Amiga that ran off of Workbench. Every other thing was a boot disk. That's just what happened.
So I'd like to end on this Casey Muratori guy. That's who this is. This is on I don't remember the 30 million line problem. Casey Muratori, how should I put this? If you want to know basically anything that goes on into how a video game gets made, this man is the man to go to. He has made an entire playlist called Handmade Hero. And if you still have questions as to how difficult a video game is to make, here is almost 800 hours. Oops, that's not what I wanted to see. I wanted to see the playlist. What is going on? Still want to see the playlist. Ba-ba-ba. Oh man, talk about talk about programs not doing what you want them to do. Well, I apologize for that image that you see. I don't know who that. Obviously, that's not Casey Muratori, right? This guy just created that this playlist. But anyway, here's almost 800 hours that goes into a single game, and this isn't done yet, right? But Casey describes almost every topic that you would ever need to know about making a game, right? Some of the things you know, oh, there's a ton of things that I didn't even mention, but one of the things that was physics related that I know a ton of is lighting. Lighting is very important, right? Someone's got to code light. They got to make light into actual existence via textual, words. Mm, there's just a ton that goes into games, and I do think I do mean I do I am serious when I mean that some of our best engineers are in the video game industry. That's not to say that all game developers are the best engineers that we have in the world, but there is a handful of the best engineers, and they can be found in the video game industry. So, also to preface, this is just another. This is also a video to describe why video games take so long. So, just some context. Mm, hope this was helpful to someone.